Hello and welcome to this episode of T-Tech. This is part 1 of 3 in our 3-part series to set up a network firewall with Linux. So the first part here is I want to introduce the concepts to you. And then in the next part, we're going to actually configure all of this on our new Linux machine. And in the third part, I'm going to walk you through checking to make sure everything is working that we configured. And during that time, I'll also explain why it's working the way it is. So, real quick, anytime we're creating any type of firewall, a custom firewall, what we're trying to do is take an internet connection from our ISP, so our internet service provider. It doesn't matter if it's cable, if it's satellite, if it's fiber, or if it's DSL. Any of the major ones will work just fine. The reason being is a lot of the modems now have an Ethernet port as the customer side of it to connect into your equipment. So we're going to have 2 Ethernet NICs that are going to plug in to our machine. So once we do that, though, and set this up, we're going to essentially have a WAN side and we're going to have a LAN side of our firewall. And the wide area network side is everything we want to keep out, essentially. Yes, we have to use it to get out to things and resources on the internet, but we don't want it talking to us unless we started a conversation, you see? So, it's kind of similar to someone knocks on your door and you check first and then you open the door. You wouldn't want them to just be able to open the door without you telling them they can, see? So the LAN side, local area network, on the other hand, is everything we have that is trusted. Now you can control what goes from the LAN to the WAN even further, but normally we allow everything from the LAN to the WAN, but nothing from the WAN to the LAN, unless it has something called state for that. But that is our setup. This is one Ethernet NIC here. This is what this line represents. This is our second Ethernet NIC. This goes into an Ethernet switch. It does not have to be what's called a managed switch. It can just be a normal switch. And then you have these PCs connected. And off of this switch, you would also have potentially a wireless access point. But with that, moving forward, if any of our PCs on the LAN want to talk, PC2, for instance, he's going to use something called ARP. That's Address Resolution Protocol, because Ethernet has to have a MAC address in order to communicate. So essentially, he would just ask for our firewall's machines. The firewall has a MAC address on its NIC. PC2 is going to ask for it, and then it's going to receive a reply from our firewall. But once it gets that, it can send any type of traffic it wants. It has its MAC address now. So, as we see, we send the packet, step 1. Step 2, the switch gets the packet. Remember, switches use the destination MAC address to decide where to switch a frame, so what port it goes out of, and it learns the source MAC address of PC2, so we don't have to repeat the ARP process after the first time. And then, though, the switch is going to forward it up to the Linux machine. Now, the next parts all take place inside our Linux firewall. So, we have something called NAT, and NAT is Network Address Translation. Now, this is only used in IPv4, not in IPv6. There's some use of it, but that is beyond the scope of what we're talking about. Here, though, we are now zooming in on the IP addresses actually assigned to our firewall. The LAN side will have 192.168.1.1, whereas the WAN side will have 192.168.0.25. And these are private because I have a network in place already that this is connected to. So this concept that we're talking about will work the same even once you plug into your ISP equipment. It works the same in a lab as it does in production. This is technically a private address. Yes, it is. but the concept of switching it out will work the same. All right? So, when that packet from PC2 comes in, its source address is 192.168.1.3. It's layer 3 address. Before it is routed out of our Linux firewall, it should be the WAN interface IP address that our Linux firewall has. Otherwise, the ISP will not route it. And as well, you could only have the first PC to send traffic would be the only one that can use your internet connection. All right? So we want to just take that source address at layer 3 in the IP header, and we want to change that to 192.168.0.25. And then after we change that address, that makes an entry, a translation entry. But once this is done, then we can route the packet. So if your computer talks to google.com, once it has the IP of google.com through DNS, it gets its address, it puts that in an IP header as a destination address. And what Linux does is its network stack looks at that destination address, and it has its routing table like as a book, and it compares that destination address value with entries in its routing table. So that allows it to select what's called the outgoing interface or egress interface to route that packet over. In this case, it routes it out of the WAN in this case. So it would route it out of the WAN. All right? And that doesn't create state. That just will route. That's why we have to have a firewall on top of the routing. Because this machine is going to do routing and it's going to do firewalling as well. It's going to do both things, but they are separate functions, even though they're combined in one machine. So, what happens when traffic comes back through? Well, the thing is actually going to happen in reverse. So the first thing that has to happen is it has to come back into the machine. And then that state we discussed, it's going to check that as another of its tables called contract. And that's the state tracking table in Linux. Once it checks that, the traffic from Google, let's say, is going to come back destined at layer 3. The source will be Google's address. The destination will be 192.168.0.25. And what will happen is Linux, if it's in the contract table, if it's part of an existing connection, will change the destination address this time. So it'll be the opposite. And it's going to change that to 192.168.1.3, which is PC2 because he started this connection. It's going to compare that destination address after the NAT reversal takes place. On the way out, we do SNAT. That means source NAT. On the way in, we do DNAT, which means destination NAT. So after the destination NAT takes place, he's going to look at that new destination and send it down. It's going to compare the routing table. The LAN address is what that address falls into. So then he's going to send it, instead of out of the WAN, he'll send it out of the LAN. So in that way, we only let the LAN talk to the WAN, but not the WAN coming in, unless we do something called a port forward, but you don't have to worry about those. And but that's what we're trying to do. That's the big picture, okay? So in the next part, I'm going to set this up on the Linux machine. All right, so I will see you in part 2. Again, this is part 1 of 3 in our Linux Network Firewall series. I hope you enjoyed it this far, and thank you for viewing. And as always, it's Tyler with T-Tech. Alright, hello and welcome to this episode of T-Tech. This is part 2 of 3 in our Linux Network Firewall series. So in this part, we've already found our hardware. We've already done a stock install of Debian Linux in this case. Alright, so the first thing you want to do is make sure you find your hardware that is, of course, compatible and has enough RAM and CPU and everything. In addition, don't forget You gotta find two NICs. You can, if you have a desktop, you can use the built-in NIC, and then you can find a PCI Express or a PCI if it's like a little bit older. And you can plug that in there and then have two interfaces. So as long as we've done that though, we can get started. And what we're going to do is log in as a user, do whatever you created during the installation. And we want to become root with the su command. And now, the first thing to do is back up our interface file. Because in order to make a LAN and WAN interface, we have to assign those addresses. So we want to back up this file here to something ending in .back. And don't be afraid to do this if once you get it running, you're messing around with it. Always make a backup of any config file on your system before you change something and you're not sure. Coming from experience, I've broken a lot of things that way, but that's besides the point. All right. Now, we have a backup. Let's go into... Oh, I'm sorry, I forgot to show you. Type IP space adder here, or ifconfig, but IP adder is a more modern way. And what we want to do is, in my case, ENPS0 number 2 there is my LAN interface. That's where that IP address will be. And number 3 there is ENP0S8. That's my WAN, okay? So that's the interface that's going into your modem. So we're going to go ahead, and now we can go into this file. And if your provider just uses DHCP, that's Dynamic Host Configuration Protocol, you can leave the WAN interface how it is. On the other hand, we used static in our diagram, so we're going to put, after init there, we're going to put static, and then I'm going to put address 192.168.0.25. This next thing after the slash is called the CIDR, the classless interdomain routing. This just means that we have octets in this IPv4 address. What the 24 represents is the bits. So an entire address is 32 bits. And what we're saying with this is 24 bits of this one address can't change. They're part of the network. So that's the subnet. So this means, because each of these sections are 8 bits, that the 192.168.0 is the 20 up to 24. Those are all 24 when you put them together. 8, 16, 24. All right? So when you put all those together, though, those are the ones you cannot change, and that's how the router knows. After that, though, we need a gateway, and it's 192.168.0.2 in my case. Always remember this when you're setting this stuff up. You want to have it must be the case that the gateway is on the same network. So if any of these sections were different, you're not going to be able to route to the gateway because you actually have to use things like ARP or NDP if you're using IPv6. So you have to have that on the same subnet. Your gateway is on the same subnet as your WAN address. Always remember that. So after that, though, let's set up the LAN address. And we need to say allow-hot plug, like this, and then ENP0S3. And now we have to say iface ENP0S3, init, static. We're going to say address 192.168.1.1, use that /24, but on a LAN interface, you don't put a gateway, all right? Don't put a gateway on your LAN. Now we're gonna hit colon and type WQ, and we're gonna write and save the file. Now you want to do if down ENP0S3. Whoops. Make sure it's /sben/if down ENP0S3, and then you want to do sben if up ENP0S3. So now if we do IP adder now, look at number 2, which was our LAN, and now it's got the address and mask we put in there. And if you look at the WAN, which is number 3 still, it has an address, the dynamic address. The reason that is we have to bring that interface down. So just do if down enp0s8, and then we want to say that same if up command. And now if we check, now we have that address. Now on your Firewall 2, we have to configure DNS servers. So to do that, you want to go into etc resolve conf. And what we're going to do here is put name server space. I'm going to put external ones on the internet. I'm going to put 4.2.2.2 and 4.2.2.1. Okay, and that will work being external. Again, let's save that file. So now we have our LAN and WAN interfaces configured. At this point, it's a good idea to do a ping. So let's do a ping and make sure you get a reply from the firewall itself. Now, we're going to go into setting up our IP routing. All we have to do is edit this file, etc.sysctl.conf. And in Linux, they've made it very easy. All you have to do is uncomment this one line, and that turns on the forwarding of IPv4 packets. And that just means it will forward a packet that's not destined for itself. From here, we need to configure the firewall. So let's go into etc initd. All right, so we have to make a program that has the rules in it and has them load for us. And we're going to make a shell program for this. So in our boot directory, we're going to make a file called fw, and we're going to start by having an interpreter line, bin bash. And now, if you're familiar with programming, and even if you're not, that's fine, we're going to make some variables, and they're just like an envelope. It holds information. We're going to say LAN, and this will be our LAN interface name, like that. Make sure it's in quotes. And now we're going to say WAN. We're also going to say LAN net. This will be our network for our LAN. So that'll be 10/24. And then our WAN will be 192.168.0.0/24. So after this, let's put in some comments for ourselves. So flush everything on, well, the firewall is called netfilter, so we'll put that in the comment. But essentially, we want to reset ourselves to a default state. We're using the command iptables-F, iptables-tnat-f, and iptables-x, capital X. And that means the chains and tables in netfilter. So we need default policies next. And what we're going to specify is iptables-P input drop, iptables-P forward drop, and iptables-P output accept. Now, the chains here, netfilter has tables and they have chains. A table contains one or more chains. Okay? So the input chain is a part of the filter table. And this input chain processes packets when they're destined for this machine. So if you start Firefox, just for instance, you don't run Firefox on your firewall, but if you start that, this data that goes up and down through the network gets processed through the input chain. So what it means is when a program is listening on a socket to receive data from the network, the data goes through the input chain. So it's for programs on this machine is what that deals with. And what the drop is the policy if it doesn't match a rule in the chain. So it's like a catch-all, okay? Forward is not for applications on this firewall itself. It's actually for routing the packets. These are the rules that decide if a packet can be routed a certain way or can't be routed. So it's not destined for this machine. It's destined for networks this machine is attached to. So our LAN and WAN, that's the example. That's what it's for. So we're going to write rules that control the LAN access to the WAN and vice versa. So everything we don't put in that chain as a rule is just going to be dropped, so it's very secure for us. Now, output, though, is for your applications when they start a connection from your machine. So input is like if data is coming from Firefox into Firefox, but you didn't start a connection. Output is like when you actually go to Google on purpose and it sends the data down first. That is okay, we're assuming. So we're going to say accept, and we actually don't have to write any rules for that chain. All right, so from here, let's go ahead and do firewall destined traffic policy. And we want to add to the end, so append any traffic coming in on the loopback interface. And we want to jump to the target of accept. And also we want to append that any traffic that has a state, so we're using a module with M there, of related, comma, and then established. We want to accept that traffic. We want to also input. We want to accept ICMP traffic to allow pings and stuff to happen. We want that to come in on our LAN interface. And accept. And then IP tables A. We want to accept some traffic for a DHCP server that we're going to set up a little bit later. Alright, that's our input first. And then next, we're going to focus on our forward chain. Alright, so now we need to go ahead and make our forward policy. Now, our forward policy is going to be for our LAN. So this is our LAN to WAN traffic policy, alright? So we're going to say IP tables, and now we're going to append to the forward chain. And then we want to say that the traffic has to be coming in with lowercase I, and we're going to utilize our variable with a $sign to tell our program it's a variable. Do LAN, and then -s for the layer 3 source address in the IP header. Now in this case, we're going to use a $sign LAN net. Now that also has to be routed out of the WAN interface like this. And then once we do that, we want to accept that traffic. Now we also want to go ahead and have it so it matches any existing traffic. So with the module state and then the -- state related, comma, established, like that, and then -j, accept. Now, the last thing we need here is that we need our NAT policy. So this is our LAN to WAN NAT policy. This is not port forwarding. This is the source NAT we spoke about. So this is IP tables. We need to work on a different table this time called the NAT table. The other ones were on the filter table. From there, though, we want to append the rule to the post routing chain. This is after the routing decision has been made by the networking stack. So if you want to do port forwards for destination NAT, you have to make the decision before you route the packet, so you have to put it in the pre-routing chain for a port forward. So from here, though, we want to make sure that it is coming from the LAN net and that it is going out of the WAN interface. And if it is, we want to jump to the target masquerade. All right? Now, one important thing for any of the rule targets, there's things like log and other stuff, but why I use drop as my policy is because it doesn't send any replies. So it doesn't send ICMP, port unreachable messages, or any timeouts or any indication that the connection failed or was being blocked. You can also set this to reject. I don't recommend it. It's good because it lets the application, like Firefox for instance, time out immediately, but it's bad because it sends back information we can use like with Nmap to gather information about our firewall if someone is in reconnaissance of a cyber attack. So you want to set that to drop, in my opinion. So from there, we should be able to save this file, all right, just like before. We want to say change mod, making it so the owner has an executable permission. Now, let's test the file we made. You want to do iptables-nv capital L, make sure everything loaded, and it did here. And then if we check the NAT table, nv capital L, we're all good on that. Now, we have to create we have to make it so this can boot up. So you want to go into, we're on run level 5, we're going to go in etc rc5.d, and then we're going to make a symlink. So ln-s, we're going to link the file we just made to S01 firewalls. We need to lastly do update rc.d, and then the name of the file we created, fw, the program, and say defaults. This hooks it all into the boot system. So when we're booting up, it goes through that boot directory for all those programs and starts them. So we have our interfaces, our routing, our firewall done. Now we have to install the DHCP server, okay? This is needed because this hands out addressing information and DNS server information. This only works for IPv4 in this configuration. After it finishes, don't panic. It tries to start, but we haven't told it what to do yet. So we want to go to etc default ISC DHCP server, and you want to uncomment the variable DHCPD v4_conf. You want to uncomment the version for PID file, and under interfaces v4 in the quotes, put your LAN interface, so EMP0S3. And then let's save that. And now the config file for DHCP is in etc DHCP dhcpd.conf. We are going to back that up just like before with our interfaces file. Want to back that up just in case. And let's remove the original. And let's make a new version real quick. We're going to say option domain name. This is your local domain name. It can be whatever you want. It doesn't actually have to resolve on the internet unless you've set that up. Now we're going to do option domain name. Domain name servers. And then let's say 4.2.2.1, comma, space 4.2.2.2. And these are external ones that our clients will use. They can be internal as well. We're going to say subnet 192.168.1.0. You want this to be your LAN subnet, and that's what's called the network ID part of it, the beginning of it, in other words. And then we want a net mask. This is a 24-bit subnet mask. That's what we need, because otherwise the clients won't know what network they're on correctly. Then we're going to open a curly brace, enter down, and tab in. So in this subnet, what we want to do is hand out specific addresses. So we want to hand out 100 through 1200, and with a semicolon. And then we want to say what our default gateway is, option routers. So remember, with ARP, this is what it tells the clients to send. It says send to me if the destination isn't on your network. And this is what that option is for. This range, the entire subnet range is 1 through 254 in our case. So just because 100 and 200 are here, you can still use 1 through 99 at the end here, and up to 254. The difference is that range will be dynamically assigned, so a lease will be created for it. All right, let's do DHCPD-T to test everything, and this is why we test. So there's an error, and under domain name servers, make sure that that is a comma and not a period. And there we go, that means it's working for us. All right, so at this point, we're going to reboot, and then we're going to verify that everything is working. So I'll see you there. So just reboot, and I'll see you in a second. All right, so this is now part 3 of 3 where we're going to verify our configurations. So the first thing I did here, we rebooted, and I'm going to do apt-get update because I'm also just going to give you guys quick tips on programs to monitor your firewall with. And what we're going to quick install for you is iftop. We're going to install iptstat, and we're going to install iptrafng. At least to start. There are others, but these are pretty good ones to use. And after that, we'll go ahead and verify connectivity. All right. So now, the first thing I want to do from the firewall is a ping. If you can ping, you know your WAN interface is correctly configured. We're also going to look at the routing table. And our routing table here is correct as well. So what we want to do is actually should have done this before, let's install TCP dump. And while that is installing, I'm going to bring up a client here. And what you're going to want to do with TCP dump is set up a listening instance of it on ENP0S3. And that's your LAN interface, okay? So we're going to fire up our client, and if I ping, because if I do route print, the 000 address is our LAN address as its default gateway. If I ping 192.168.1.1, you can see the echo requests and replies. But if I ping Google instead, you can see that it had to go through and send an ICMP echo request. It already got the IP from DNS, but all right. Now we're going to go to the WAN interface, EMP0S8. And if we ping, you'll see the traffic is different on this side. Because of that NAT rule, it changed it to 25. So if we look at our NAT table, you see it's caught 11 packets, and it's changed the source address of them. But that's how that works and why it works. So again, just to reiterate, check your LAN and WAN when it comes back up. Check your routing table with IPRoute or netstatrn if you have that. And you also want to do systemctl, status, DHCPD. Whoops. It's actually spelled out, ISC DHCP server with hyphens in there. And you want to make sure that's running as well. One last thing I'm going to leave you with is what happens if you want to have SSH. So SSH is secure shell on here. So if I install SSH, and now if you don't know what SSH is or why you would need it, don't follow these instructions because this is an avenue of attack for breaking into systems, as well as its purpose, which is securely administering those systems over a network. But anything can be used in a malicious way as well. If we install that, I'm just going to show you real quick. If I start this SSHD, and then I run, if I look at SSLN, whoops, too many, SSLNT, it's listening on port 22. And what you have to do is actually open that up in your input chain, but we have to be very careful about doing it. So we're going to say it here, but let's open it up. Only do this how I'm showing you. Please, I mean, do not open this up to your WAN unless you know why you need to do it. So here we're going to use that $ again, LAN, TCP, not just TCP, but let's also have it only be our LAN net source, have it be TCP, have it going to port 22, and accept the traffic. So basically what this means is it's only going to allow, if we look at that table input, it's only going to allow that traffic to the SSH server if it's from our LAN net and coming in on our LAN interface. This is a pretty secure configuration. So why it's important to have this is now I can SSH to that machine like this. Then I say accept the fingerprint, and then I can log in. The problem is it's over the network. I don't have to be in front of the machine to do this. This is why I limited it to the LAN interface and only our trusted computers. See, now if I say W, I'm logged in from an IP address that's remote, and that can be any IP address. Real quick, just to round it all out, if we tail the file verilog auth-log, that's how you can keep track of who is logging in, and if what you want to look for is accepted password, if that comes in for a user from an IP you're not expecting, or from the WAN, you need to look into that. That's why I said do not open this on your WAN. It's impossible for someone on the WAN right now with this configuration to get in. But they could break into your LAN and use it as a pivot point. There's many other ways as well, but regardless, with that, the other programs like IFTOP, you can just use these to monitor your LAN and WAN. You would see connection information. IPTstat is the same way. You can monitor information with your connections, and as well. So that's how those work. And IPTraf is another good one. You can monitor interfaces and things like that. So if I ping right now, I can monitor that connection. You see packets down there? So like if I do a continuous ping, I can go through these interfaces here and see all of the packets and their bandwidth and everything, as well as like statistical breakdowns by packet size on my LAN and WAN. See, these are 75 byte packets. And I can monitor my LAN stations. So I can monitor the MAC address and the frames that are coming in from my LAN. So that is how you set up a network firewall with Linux. And these concepts, a lot of them, they all apply to any distro you're using. So I hope this was helpful for you. So with all that, as always, it's Tyler with T-Tech.